Hey everyone, I welcome you all to the fifth video of Module 4, and here mostly we'll be talking about how you can create this NumPy arrays in multiple different ways. We're going to start with arrange, then we'll be talking about linspace, zeros and ones. These are the ways through which you can create this kind of NumPy arrays. Again, these are not all the ways through which you can create NumPy arrays, but at least some of the ones that you should at least know about. And then we'll also be talking about how you can reshape an array that you have created, how you can change the data type of it with the help of this S-type functionality. So all of these things will be covered in this video. So let's get into it. Now let's just go ahead and let me see what is the next title. It's going to be fourth, right? It's going to be the fourth title that I'm giving. And now let's go ahead and understand about some different ways to create NumPy arrays. And this is one of my favorite part in NumPy, all right? So I'm going to give you some bunch of ways through which you can get this done. So the first thing is arrange. What happens over here? It's basically array of range. How does a range work? I have explained this part when we were dealing with the for loop. It's just like that, okay? But now you are just going to convert it into NumPy array. So if I have to create an array, which is going to, let's say for example, go in between 1 to 9, just like what we had done over here, just like this 1 to 9. How can I do this? But a 1D array, okay, not a 3x3. Then how can I do this? With the help of arrange. I can simply say np.arrange. Then what do I need to tell? What is the starting value? It's 1. What is the ending value? It's 9. But just like range, the output value is exclusive. So it's going to be 10 in this case. And then what is the step size? I want to skip 1 unit. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So by default, it's always 1. So I'm going to keep it 1 only over here. Even if I don't write it, it's going to be 1. Let's check the output. You can see that we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9. This is something that we wanted. A 1D array with the values in between 1 to 9. And we have created this with the help of this arrange functionality. Now on top of this, let's say if you want to reshape it. How can you do this? For example, I'll just save it over here. Arrange array. Let's say, and this is something that I've created, arrange array. All right. Now after this, let me just tell you that how you can reshape this array into 3 by 3. So I just need to use this functionality of NumPy called as reshape. So I take that array that I want to reshape and say dot reshape. I just provide bunch of input, that is what is the shape of this array. Because I know that there are 9 elements, I can split it into any combinations of 9. Okay. So the one that is coming into my mind is 3x3 because 3x3 is 9, right? So 3x3 is something that I can give over here. Actually, it's 3, 3, not 3x3. You can see that now you are having the same type of output that you had seen over here, right? I'll just print array over here, also print arr3. So if you do this print, it does not give you that kind of an array. But if you are displaying this without that print, it gives you this kind of an array, right? So for example, if I just go ahead and do print of this, you will see that this array is going to be vanished. But it's just essentially an array, all right? It's actually an array. So yes, this is something that we really wanted to create. And let's say if I want to now change its data type, how can I do this? How can I convert this into float? Okay, convert this into float 32 data type. Now, how can I do this without having this kind of D type argument? I can do this with the help of AS type, all right? So whatever is the array, that is, let's say this is the array that I want, but for that I'll have to save it, right? First of all, so I'll just go ahead and save it over here. Reshaped array. I'll also print it, reshaped array. And over here, I'll say that I want to take that reshaped array and do AS type to np.float. Oops, just a second. np.float and 32. Okay. So what I have done is I have converted now the data type of this reshaped array into np.float32. But now before this, let me just go ahead and tell you what is the data type currently. Check the data type of reshaped array. Okay, isn't this interesting? One after the other things, we are keep on experimenting. That's the beauty of NumPy. Okay, and yeah, that's how you should explore this type of functionalities of NumPy. So what I'm going to do is I'm going to take that reshaped array And what should I write? D type, right? Clearly it's some bunch of integers over here, so we can see that it's integer 64 data type. Now I'm going to convert it into np.float. So let me just say that reshaped array, but it's going to be float now. Okay, this is something that I'm just naming it, and I'm also going to copy it and I'm going to paste it to see how it's going to look like. And you can see that the data type indeed is float 32 now, right? You can also go ahead and check this dot d type just like how we did above, and even that is fine. You can see that it's now float 32. That's the magic of this S type. If you are not having this kind of a functionality through which you can change the data type, you can surely go ahead, take any type of array, use this S type on top of that, and just pass whatever type of conversion that you would like to have in the data type, right? So yes guys, that's about how you can use this kind of arrange functionality and do a lot of things on top of that, right? But now let's stick to what is the original title that we have given over here, that is different ways to create NumPy arrays. So the one I hope is clear. I'll just give this one on top, just next to that. And now the second thing that you can use over here, apart from arrange, is what? You can simply go ahead and use, for example, linspace. Now what is the power of linspace? It's going to give you an array. I'll just use np.linspace. It takes what is the starting value of that array, what is the ending value of that array. Okay, let's say I'll give you 5. And how many points do I need to have in between that starting and ending? So if I give 4, let me run this and show you what's going to happen. You can see that I'm having 1, 2, 3, 4. In short, it tells you how many numbers you need to have in your array. Okay, how many numbers, and then it's automatically going to get you this equidistant array. Okay, so the distance between these two things, if you take the difference between them, will be the same as the difference between these two numbers. Similarly, the difference between these two numbers will be same. That's the power of linspace. So if I just go ahead and show that to you, 2.3333 minus 1 is what? It's 1.33333. Now what is 3.6666 minus 2.333? Let me just show that to you. 3.6666 minus 2.3333. It should be 1.333. See that these are having the same type of difference between them, and that's what we use NumPy for. Okay, that's the reason why we use NumPy. Right, I'll just delete all of this, and I can also store this into some array and do a lot of stuff like what I've been doing for this arrange. Right, I'll leave that up to you. You can explore this on top of this. I'll just say that this is linspace array. Okay, let's run this again and display it over here. Linspace array. For example, let's say if I want to have 1 to 10, so in between this 1 to 10, let's say I want to arrange 9 different values. This is how it's going to look like. What if I change this to 10? Because I'm having 1 distance and I want to arrange 10 different values in between 1 to 10, this is how it's going to look like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is a difference of 1 units in between them, as you can see, right? What if I want 20 different elements in between 1 to 10? This is how it's going to look like. What if I change this to 5? This is how it's going to look like. You can just go ahead and play with this kind of numbers, right? So that's about linspace, guys. After the linspace, 2 of my favorite ones are np.zeros and np.ones. So I'll just first of all begin with zeros. What I'm going to do, I'm going to create arrays of zeros. Okay, array of zeros. np.zeros is what I need to use. Then whatever is the shape I want to create the zeros, I can give it. For example, let's say 2 cross 2. And now if I print this array of zeros, you will see that it's a 2 cross 2 0 0 0. See, that's the output that we got. Again, this is an array, right? Just like this, I can do this for ones if I want. Okay, instead of zeros there will be ones, simple as that. And if I, let's say for example, want to add a 1 over here, I can just do this plus 1. It's going to add 1 everywhere, and it's 1 1 1 1. It's just a trick that I keep on using. But yeah, if you want to create ones by default for yourself, how can you do it? Let me give this name as arrays of ones over here. So np.ones, it's the name is np.ones. Again, it's going to take some kind of shape. Let me give it like, a shape of 3 cross 3 at this time and print this arrays of ones. And if I just run this code, you will see that it's 1 1 1 1 1 1 1 1 1 1 1, right? It's 3 cross 3. So yes guys, that's how you can create a bunch of different ways through which you can create this kind of NumPy arrays. On top of this, there is one more important type of ways through which you can create an arrays, and that is with completely random numbers. Okay, and that's something that I'll be showing you in the upcoming video. But yeah, I guess all of this is enough for this particular video over here. Alright guys, that's the end of the video over here, and I hope that by now you are feeling much confident in order to create your own NumPy arrays in multiple different ways, and then what are some of the properties associated with them, and if you want to access it, change it, how you can do all these kind of things. Now in the next video, we are going to look into one of the module of NumPy called as random. So I'll see you over there.